Okay, so in this video right here, we're going to review triangle congruence, all right? So we're going to cycle back to stuff we've previously done. Why? We got some, we got to keep it refresh in our brains for a variety of reasons. This stuff's going to come back. So we're going to utilize this time to review triangle congruence, all right? So we're going to do a two-column proof, because why not? All right, given AB is congruent to BC, and D is the midpoint of AC, we're going to prove that triangle ABD is congruent to triangle CBD. All right, so this probably all sounds familiar, but you might have forgot a lot of stuff. We haven't done a two-column proof in a long time. Let's just take it slow. All right, let's just do stuff we know first, such as that's my first statement. It's what I'm given. Okay, that was given to me. That's my first statement. Furthermore, I can actually draw that on my picture. All right. And D is the midpoint, so I know that AD and DC are congruent, which is actually my next statement. All right. It told me it was the midpoint. I'm going to apply the definition of midpoint, and I can say that AD is congruent to DC. Okay. So remember, it gives you specific information because you're going to use that information later on. Now, there's also stuff we can tell that's true by just looking at the picture. In this case, we have this shared side BD, and specifically we know BD is congruent to itself by the reflexive property. Again, we spent a lot of time practicing this, just been a while, so a quick refresher in our brain. Now again, some people struggle with two-column proofs. However, there's some absolutes, such as you must never miss the last reason or statement. We always have to state what we're trying to prove. All right? You always have to finish with what we're trying to prove. Now, the reason isn't proved. It isn't given. There's a specific reason. And in this case right here, it's the side triangle congruence theorem. We're just going to write side, though. All right? So remember, we have all these triangle congruence theorem. If three corresponding sides of one triangle is congruent to three corresponding sides of the other triangle, then the triangles must be congruent. All right, so that's a cool, fun two-column proof from the past. Now refreshing more stuff in our brains. In the figure below, if AC is congruent to DF, so again, just draw on our pictures. Drawing tick marks are very powerful. Now again, it seems like a lot of students forgot this. AC is congruent to, or angle A is congruent to angle D. Arc marks. These arcs right here say that those angles are congruent. Don't forget that arcs tell you what's congruent to what in terms of angles. All right, so in the figure below, we have a side and an angle for both of these triangles. Which additional information would be enough to prove that triangle ABC is congruent to triangle DEF? All right, so let's just review some things we have. I'm just going to use the letters. We have side. We have side, angle, side. Oops. We have angle, side, angle. We have angle, angle, side. And we have HL. All right, so which additional information would be enough to prove that triangle ABC is congruent to triangle DEF? Well, there's two that we can't use. We can't use side. We can't use HL because we only need one more piece. All right. Now, if I want to use side, I can say that AB is congruent to DE. If I just know that those two sides are congruent, then I'm going to have side, angle, side, because the angle is included angle. It's sandwiched in between the two sides, just how the A is between both S's. All right. If I want to do angle, side, angle, I could have also said angle C and angle F. Angle C is congruent to angle F. All right. That would have gave me angle, side, angle. And then the last one is, let's clear off what we have to make it more obvious, because between angle, side, angle and angle, angle, side, just dropped my stylus on the computer. If it's this angles right here, angle E and angle B, notice how then it's angle, angle, side. The side is non-included. The side it's not formed by both angles. All right. So just depending on what theorem or postulate we want to use, it could have been any three of these. Pretty interesting stuff. HL only works for right triangles. This isn't a right triangle. Side, side, side. We only had one side, so we couldn't use that one. All right. Now, which method listed below cannot be used to prove that the true triangles are congruent? All right. So again, this is kind of the same question as before, just structured differently. Prove all three sets of corresponding sides are congruent. All right. This actually works. It's saying which cannot prove that triangles are congruent. And again, our choices are to help us steer our directions. This is the stuff that does prove triangles congruent. So prove all three sets of corresponding. That works. So I'm gonna put an X because that's not gonna be an answer. Or I'm gonna cross it out. How about that? All right. Prove that two sides. All right. So two sides and an included angle. All right. So again, the included angle means that it's going to be side, angle, side of one triangle are congruent to an included angle, two sides and included angle of another triangle. All right, so two sides we have S, S, and the A goes in between the S's, so that works. So this isn't going to be our answer. Prove that two angles, so now in this case I have an angle and an included side. So again, included means it's between the angles of one triangle are congruent to two angles and an included side of another triangle, so that again works. And then the last one is prove all three sets of corresponding angles are congruent. That would just be angle, angle, angle. That does not work. Remember, angle, angle, angle does not guarantee sides congruent. All right, and again, just really quickly, you could have two equilateral triangles, one big, one small, not congruent. And then last question right here. All right, given E is the midpoint of CD and angle C is congruent to angle D, which of the following statements must be true? All right, so again, before I even look at the statements, let's just draw on my picture. E is the midpoint of CD. So tick, tick. And then C is congruent to D. Okay, so then what happens from here, does angle A have to be congruent to angle D? No, they don't have to. Does angle B have to be congruent to angle C? No, they don't have to. Does CE have to be congruent to BE? No, they don't have to. So really what's going on in here is this is a slightly advanced problem. Let's focus on this. So this triangle here, we have this side, this angle, and then this triangle over here, we have this side and this angle, and then we also have these vertical angles right here. So these triangles are congruent to each other by angle, side, angle. So since the triangles are congruent, all the parts are congruent. So in fact, it's actually that AC and BD will be congruent. This one was a little bit tough because we had to first say, well, the triangles are congruent. So what has to be true? Well, AC and BD, those are corresponding parts. So they must be congruent. All these other ones weren't necessarily corresponding, so they didn't have to be congruent. Corresponding parts of congruent triangles are congruent.